All right, so you know how when you have a function and you draw a graph and it's like the visual representation of that function, like you would graph x squared and get a parabola, it's a visual of it. So a slope field is a visual representation of a differential equation, which is kind of cool because it's a representation of an infinite number of solutions. So it represents an infinite number of solutions, which I think is just cool that you can represent an infinite number of answers like visually. I think that's neat. Now, these are tedious to do. We were just talking about that. You remember it from last year. But if you only have X or you only have Y, that actually makes it a lot less complicated. If you only have an X, like the Y is missing from the differential equation, then all your columns are going to be the same. So you can knock out whole columns at the same time, and that speeds up the process. You don't have to go like tediously point by point. And if you only have a Y, then that means all your rows are the same. So you can knock out like a whole row at the same time. Also, even though these are tedious to do point by point, on the AP exam, they usually will only give you like 5 or 6 points you have to do. It's not that many. Like I'm actually kind of going above and beyond here by giving you all these points. They don't ask you to do this many. So yeah, you have to do point by point, but they don't usually give you more than like a handful of them. Now, I want you to make the connections between the slope field and the differential equation. So we're going to do all these things. We're going to draw it, describe what it looks like. That's like, say a few words, like what would the solutions look like? We'll solve the differential equation, and then we'll solve it for one particular answer, and we'll find that one particular answer on here, because this is going to, again, be an infinite number of answers. So we'll find like the one particular answer. So what do you notice about this differential equation? It's only X. We're going to knock out whole columns at the same time. You can start wherever you want. I'm just going to go left to right to, stay organized. So for this whole column, X is -2. If you plug in -2 for X, what do you get? 3. And dy dx is a slope. That's why it's called a slope field. So for all those points, your slope should be 3. Now, it's not going to be perfect. It's going to be good enough. You guys are all pretty mellow, but I do get people that are very type A and like want it to be perfect. It's not going to be perfect. It's going to be good enough. Okay. So slope of 3, something pretty positive, like that-ish. And as long as they all look the same, then you're good. They really just need to make sense in relation to each other. Like this one is steeper than that one or whatever. They're not going to be perfect. Right. Then we can knock out this whole column at once. What is X for this whole column? What is X for this whole column?
Oh.
-1. Are you following me there? We're all just asleep. Okay. If you plug in -1 for X, what do you get? 2. Now, if this was 3, you just need 2 to be less steep than that. Again, it's not going to be perfect, but just make it less steep than the one you just did. It usually like looks good once you get the whole big picture and you can like see the whole thing. Let's try again. What's X for this whole column? There we go. If you plug in 0, what do you get? 1. So if this is 3 and this is 2, you want 1 to be like even less steep than that. All right. And now what is X for the next column? 1. If you plug in 1, what do you get? Now that's the only one that you kind of can draw really specifically because 0 is going to be horizontal. So 0 slope for all those. And then last column here, X is 2. If you plug in 2, what are you going to get? -1. So look, if this was +1, what we did for this column here, -1 needs to look like the same amount of steepness except negative. Again, they just make sense in relation to each other. So again, that is an infinite number of answers. Let's describe what they would look like. If you were to draw in following these slopes, what would the graph look like? An upside down quadratic, a flipped parabola, however you want to say that in your own words, a reflected parabola. And it's cool because it's an infinite number of parabolas. You would have one here and one here and one here and one here and one here. Isn't that cool? It's an infinite. It's cool, guys. Cool. I'm right, you can disagree. This is neat. All right, so now we're going to work it out. If it's upside down parabolas, what should we get in our answer? A negative x squared somewhere. Okay, I want you to make these connections, right? Multiply over the dx, so we'll have dy equals 1 minus x dx, and then antiderivative. Oh, I forgot to put the 1 in front of the dy. What's going to be over here? It'll just be y equals antiderivative of 1, the x, minus, oh my gosh, it's a minus and an x squared. And then at the end, plus d. So that's the in general solution, the general solution. So it's like an infinite number of answers. Now we're going to find one particular solution for this initial condition. So the one that goes through the point 0, 1. So if you come over here and you plug in 0 for x and 1 for y, what is going to be your constant? Plug in 0 for x, 1 for y. 1. And so your particular solution is y equals, and you can just copy this, except with a 1 in it. And so we're going to draw in that one particular solution over here. You only have to start at the point they tell you to start at, and then kind of swim with the fishes. Like you just go with the slopes and follow through them. So you're going to start at 0, 1, which would be right here. So you start at that point, and then you just kind of like, I don't know, this is like such a crap explanation, but you just like flow with the slopes. Do you see what I'm saying here? Like it's just gonna do something like that. Do you follow me? Now, the only thing I am gonna say though is, because they sometimes have you do this on the AP exam, and I actually kind of hope that they do have you draw one of these in because it's a really easy answer to get. You have to draw your curve all the way to the edges of the grid. For example, if you were to stop here and not finish it off to the very edge, they won't give you the point. But sometimes they'll throw one of those on the exam and it's worth a point. You just draw it in and you get a point. Brilliant. Okay, so you just start at whatever point they tell you to start at and then swim with the slopes. Cool. Just going to practice that a few more times. All right. So what do you notice about this differential equation? There's no x. That means we can knock out what? Rows. You can do the whole row at once. I'm just going to start at the top, work our way down. What is y for this entire row? 2. If you plug in 2, what do you get? 1. So your slope for this entire row is 1. Good enough. Like it's not going to be perfect. Just in relation to each other, they have to make sense. What's y for this whole row? 1 is now you're jumping straight to the answer. So y is 1. If you plug in 1, you get 1/2. So if these slopes are 1 and you want these to be 1/2, they just need to be less steep. So again, as long as in comparison to each other, they make sense. And then what's going to be your slope for the next row? All of them are 0. And then down here, it's going to be the exact same thing we had up here, except reflected, like your y values are negative. So for this next row, you're going to get -1/2. And then the last row would be -1. So try to make them look exactly like the ones you did above, except negative. And again, I'm not here to like grade your art skills. It's just like, good enough. So let's describe what they would look like. If you were to draw in a curve, like following along with these slopes, what would it look like? Well, I'm looking for like I like that you're creative, but I'm looking for like there we go, exponential. And you have a horizontal asymptote where? Y equals, and thank you for saying the y equals, because I thought I was going to have to like pull teeth with that one if someone just said 0. exponentially going to have a horizontal asymptote at y equals 0. It's an infinite number of answers, though. You could have them up here, or they could be reflected and be down here. Okay, so it's an infinite number of them. So when we solve this, we're expecting to get something exponential, okay? Now you have to move the y over. How would you do that? Multiply or divide? Divide the y over. So it'll be 1 over y dy. And when you multiply over the dx, what's left over there is not 2, it's actually 1/2. Good, because the 2's in the denominator. All right, so antiderivative. What's our antiderivative for 1 over y? ln of y. And then over here, antiderivative of 1/2 would be 1/2 x plus c. Kind of like the antiderivative of 1 is just 1x. The antiderivative of 1/2 is 1/2 x. Like if you just have a number there, like a constant, it'll just be that with an x. And then how do you cancel out the ln? We want to get y by itself. Do you remember what the official word is, though? Good. Well said. Exponentiate. So you're going to get y equals, e is a number, c is a number. So do you remember what we do with that? It'll just go out front, e to the power 1/2 x. And then because it's an infinite number of solutions for the absolute value, we put plus and minus. And again, that's because the answer might be up here or it might be down here. So that's your general solution. And it's exponential like we said it was going to be. So now we're going to find our one particular answer for this initial condition. It doesn't start at 0. Just be careful. It's whatever number you're given. You're going to plug in 2 for x right here and -1 for y. Hey, Ms. Cole, why don't we plug it into this one? You want to do the plugging in before you've done any rearranging because we've kind of really messed with this a good bit. You want to go back to like right when you did the antiderivative. So if you plug in 2 for x, 1/2 times 2. We're going to plug in 2 for x. So 1/2 times 2 would just be 1. So we have 1 plus c. If you plug in -1 for y, absolute value of -1, 1, and ln of 1 is 0. So what does that mean c is? Yep, c is -1. So I'm going to recopy this line and plug in -1 for c. Oh, whoops. I just said I'm going to plug in -1 for c. And I wrote c anyway. And then you're going to exponentiate both sides. But you're not going to put a plus and minus. You're going to make a decision. Do I want the plus or do I want the minus? And do you remember what tells us? Like what piece of information over here tells us that? Your initial condition. Because it's negative, we want the negative version. And we're about to draw it in so you can see it. I love this lesson because it ties together like everything. Like you can make connections between all these. That's why I have you do this for every problem so you can tie it all together. So what point were we starting at? 2, -1 is right here. And this is really kind of close to the edge, so it's going to kind of go off the grid, but it's going to do something like this. I'm going to skip around on here real quick. And so that's our one particular answer out of this infinite amount of answers. Do we get that? Okay. Go to the last one, number 5. I'm going to pause the recording real quick. I want you guys to try that one together and then I'll go over it. So what do you notice is missing in the differential equation? So since there's not a y, can you do rows or can you do columns? Columns, okay? So what kind of a slope did you get for this first column? X is -2. 12 would be very, very, very steep. You want to draw something that's like nearly vertical. All right. And then how about this one? You would get 3. So like still pretty steep, but not as much as 12. And then how about here? 0, which is the easiest one to do because it's just going to be horizontal. And then how about this one? 3 again, so try to make it look the same as whatever you did for that one. And then the last one will be 12 again, right? So like practically vertical. So if you were to draw in like a 0 slope here and then have it kind of flow along with these slopes, what would it look like? Like, how did you describe them? Cubic, good. All right. And then when you solve this, just multiply over the dx. And what did you get for your antiderivative? Y equals? Good. Oh my gosh, there's a cube. And then for your initial condition, if you plug in 0 for x and 1 for y, what's your C value? Just B1. So there's your one particular solution. And so all you have to do is start at 0, 1, which is right here, and then just like flow along with the slopes. And just like make sure you go all the way to the edge. That's the one thing they always say to do is like if you don't follow it all the way to the edges of the grid, then they won't give you the points for it. All right. The reason why these are a little bit tougher, and actually I may pause and like let you guys try that. You can divide and conquer this, is because you have both an X and a Y. And so you do have to go point by point. However, there are some tricks to like knock out a little bit of it at a time. What could you plug in for Y that would be like a good number? If you plug in -1 for Y, what are you going to get? So when Y is -1, you're going to have 0 slopes. And then also look at X. If you plug in 0 for X, you're going to have vertical undefined slopes. The only point where there's like a major issue is where you have 0 over 0. Do you remember what that's called? It begins with an I. Good, indeterminate. Good on the vocabulary. At that point, you should put nothing. That one should remain blank. So what I usually do is like bold that one to make sure that like, because if I leave it blank, I feel like I forgot to do it. But if I bold it, then I'm like, oh, I took care of that. It's just, it should remain blank. So it would be when X is 0 and Y is -1, that would be this point right here. So what I usually do is just like go like that. And it reminds me, you don't have to do that. It's like a personal preference thing, but it reminds me like, hey, I did that one. I didn't forget about it. It's just, it's supposed to be blank. Does that make sense? Like you should put nothing on that one because it's indeterminate. But we said when Y is -1, so that'd be this whole row, we're going to get 0 slopes. And then when X is 0, which would be this whole column, we're going to get undefined slopes. So something like that. So we did knock out actually like a good bit of it, like all at once there. Let me go ahead and hit pause and we'll sort of divide it up. So there's our slope field, and then we want to describe what it looks like. Remember, we're indeterminate here. That means you're not going to get a derivative at that point. Let's remember some ways that you don't end up with a derivative, like the not differentiable. What's the most common one? Because that's actually what this is going to be. Not differentiable due to... Oh, you guys are remembering the less common ones. You could have an asymptote. That's not what this is going to be. What did you say? Sharp edge. Okay. Remember, not differentiable due to sharp edge. Okay. So you're going to have a sharp edge there. And then if you follow along with these slopes, what would the graph look like? Like you could follow along with these ones or those ones. It's going to be absolute value is what this is going to look like. And it's an infinite number of absolute value graphs, which is cool. So it's absolute value. And where's the sharp point? Sharp point is at 0, -1. Perfect. So it's an infinite number of those V shapes, but every single one of them would have its sharp point there. That part's not going to change because that's our indeterminate point. So when we go to solve this, we should end up with an absolute value, and we will, okay? So how do we move over the Y plus 1? And you kind of have to keep that Y plus 1 together. It's all like one item in the numerator. Would you multiply or divide? Divide. So it's going to be 1 over Y plus 1 dy equals, it's not X on the other side. It's actually 1 over X dx. Antiderivative. So on this side, you're going to get ln y plus 1. We didn't need a u substitution because the derivative of y plus 1 would just be 1. If it was a 2y, you would need to adjust with 1/2. Okay, like you would just put that out front here. All right, equals, and then on the other side, ln of x plus c. And then you want to get y by itself, so you're going to exponentiate both sides. You're going to have y plus 1 equals, and then let me talk us through this. E is a number, c is a number, so we would put that like c out front just as one big constant. And then usually you would have e to the power whatever's left, but e to the power ln x, here, don't write this. What's going to happen? E to the ln x, yeah, like e and ln are going to cancel, so it'll just be absolute value of x. And then because it's the general solution, it's an infinite number of them, you have that plus minus in there. Phew. And there's actually one more step to get y by itself. What would be your last step? Yeah, minus the 1. But here's the connection I want you to make. Like that does make sense with what we have here. You have an absolute value. It moved what direction? Down 1. That's why the point is right here. And it could be positive. It could be like upwards like this, or it could be negative. It could be down here. And changing this C number changes, you know, the steepness. Do you get what I'm saying? Like you could have a V shape anywhere through here, positive or negative. Are you making the connection? What that is. Now we're going to find one particular answer for this initial condition. You don't want to use this part that you've rearranged. Go back to right after you did the antiderivative, okay? Because we kind of made it more complicated with this. So if you plug in -2 for x, absolute value of -2 would just be 2. So it's just ln of 2 plus c, you know, whatever ln of 2 is. I don't know what that is. And if you plug in 0 for y, what are you going to get? So ln of 1 is 0. So what is c? Good, negative ln of 2. Good, thanks for sticking with me through them. Because these ones are a little bit tougher. So I'm going to recopy that line, except put in minus ln of 2. So I just recopied all of that, but instead of c, I put minus ln of 2. And then we're again going to get y by itself. And it's going to be really similar to what we did over here, except we're going to get like an actual one particular answer. So if you exponentiate both sides, it's going to be y plus 1 equals divide. So when you do e to the power of both of these, the ln's are going to cancel out, and you're going to have this over this. So it's going to be absolute value of x over 2. It comes from your exponent rules. When you multiply, you add exponents. When you subtract, you divide, or excuse me, when you divide, you subtract your exponents. And then what would your last step be? Subtract 1. And I'm actually going to write that as a 1/2. That usually like sits better with everybody. 1/2 absolute value of x plus 1. It's a vertical shrink by a half. It's like an elephant came by and sat on the graph. It's going to be less steep, which you're going to see in a second when we go and draw it in. What was the initial condition? -2, 0. So all you have to do is start at that point, which is right here, and then follow along with your slopes. So -2, 0 is right here. I'm going to go through that point, and it's going to follow along like that. All right, we're going to try one more. Let's find the point that's going to be indeterminate first. What would x and y be for the indeterminate point? -1 and 0. Do you see that? You would end up with 0 over 0. So -1, 0 is going to remain blank. And you don't have to put anything there. I just usually bold the point. Let's try and find out some other rows and columns we can knock out like all at once. Like, do you see something we could do that would be a clever thing where we could knock a whole bunch of it out at once? -1 for x is going to give you what slope? 0. So when x is -1, which is this whole column, you're going to have 0 slopes. And then what else? When y is 0, we're going to have vertical, undefined slopes. So for this whole row, we're going to have undefined slopes. Now there's going to be a lot of like reflecting. We'll just go through this one together. I was going to divide it up again, but I don't want to pause the recording again. All right, so what is this point? -2, 2. If you put in -2 for x and +2 for y, what is that going to be? -1 over 4, -1/4. So like very not steep. You can reflect that over here. And then this point is -1, 1. So that, or I'm sorry, -2, 1. So if I put in -2 for x and 1 for y, that would be -1/2, which would be a little bit steeper than -1/4. So just like a little bit more negative than that one, and then reflect it over here. Again, they're not going to be perfect. They just have to make sense in comparison to each other. Now let's go over here and get these ones, because then what we're going to do is take all this and reflect it down here. So what is this? 1, 1. If you plug in 1 for x, 1 for y, what is that? 2 over 2, which would be 1. So that's actually going to be more steep than anything we've done so far. This point is 1, 2. What is that going to be? 2 over 4, which would be 1/2. That's actually the same as this one. So try to make it look the same as that one. Almost there. We can do it. Hang in there. This point is 2, 1. So if you plug in 2 for x, 1 for y, that would be 3/2, 1 and 1/2. That's more steep than any of the other ones we've done so far. So like in relation to the others, make it more steep. And then 2, 2. What would that be? 3/4. So like somewhere in between those, good enough. Okay. And then what you're going to do is take all that and reflect it down here. So just take all of those slopes and reflect them down here as best you can. Again, it's not going to be like perfect. Now, when we go to describe these, I don't expect you to know what these are called. They took this out of the Algebra 2 curriculum. We used to teach what these graphs were. You know how in Algebra 2 you learn all the graphs like quadratic and cubic and exponential and all those? We used to do these, but they took them out, so we don't learn them anymore. These are what are called hyperbolas. Hyperbolas are really cool. They can either be vertical. This would be a vertical hyperbola. And yes, those both count as part of the graph. It's not a function. It fails the vertical line test, but that's like a vertical hyperbola. Or it could be sideways and look like this. That's a horizontal hyperbola. Do you see what I'm saying? And they have what's called this like center point. It looks like it's belly button sort of. But like that's where it's centered. It doesn't actually go through that point, but that's just where it's centered. And they're really cool. That's what these would be, are hyperbolas. Do you see how you could have one going this way? Or you could have one this way. It's like parabola, but hyperbola. I wish we still taught them. I don't understand why it's gone, but they took it out. So when you go to solve this, and I promise this one will be more straightforward than the last one, you can actually just cross multiply. It'll be 2y dy equals x plus 1 dx. Antiderivative. So what's our antiderivative on the left side? Y squared, good, equals 1/2 x squared plus x plus c. Awesome. And then you just have to get y by itself. How would you do that? And because it's the general solution, which is an infinite number of solutions, you have to put plus or minus. Good. So y equals plus or minus square root of all of that. And then when you go to find one particular solution, I'm going to cover that up because we ended up messing around with it. We're going to plug in -1 for x, +1 for y over here. So that would give us 1 equals, all right, if x is -1, -1 squared would just be 1 times a half would be a half -1 plus c. So what is this going to give us? Let's put that together, like our like terms together there, so to speak. A half minus 1. Negative a half. And then add that over. So what is c going to be? Yeah, 1.5 or 3 halves, however you want to do that. And so you would recopy this, except put a 1.5 in for c, and then you would square root. Now we're not going to put the plus and minus. We're going to make a decision. Do we want the plus or do we want the minus? It comes from this number right here. Plus, your initial condition is positive. And I always get, but hey, this number is negative. Well, it's the output that we're talking about. It's y equals. You want to look at the y number. So positive square root. And again, just copy all that over, but put 1.5 for c because it's our one particular answer. And when you go to draw it in, all you have to do is start at the point they told you and swim along with the slopes. So -1, 1 is right here. And you're just going to kind of like follow along with that. And if you finished off the hyperbola, you would get another part down here. We're just doing this one piece of it. But like a whole hyperbola is technically like both arms of it. I don't know. I think hyperbolas are cool. I wish we still thought them. They're neat.